be presenting to you the effect of inhaled cadmium oxide nanoparticles on hypoxia-inducible factors 1 alpha and inducible nitric oxide synthase in maternal organs and placentas in CD1 mice. So, in 2010, McDonald's released Shrek drinking glasses as part of their Happy Meal plan. What they failed to realize was that these cups were coated with a cadmium paint. McDonald's quickly recalled the cups, and any damage done to children were paid off by the company, and there were no lawsuits done. However, what this incident brought up was the dangers of cadmium in society and how prevalent they are in everyday life. Now, cadmium is known for its use in batteries, paints, and many other household items. Because when ionized, it becomes a bright orange or red, it is used widely, like lead paints, mercury paints. However, it's also been found in tobacco smoke, car exhaust fumes, and major pollutants. Now, as I said earlier, cadmium is found to be very poisonous to the human body, possibly causing death. When accumulating in both the kidneys and liver, it can cause failure in those organs and then again lead to death. It is classified as a Category 1 carcinogen by the IARC, which is the highest degree possible given. So it can either be ingested or inhaled as either sustenance or as smoke. So, now specifically, I looked at the effects of cadmium oxide nanoparticles, specifically again, quantum dots. Now these quantum dots are a cadmium core with a cadmium cilium or cadmium thallium surrounding, and when ionized, the ionic component around it is released, and you're left with pure cadmium, which can be inhaled by mice, humans, or any organisms. These chemicals are approximately 5 nanometers long and invisible to the human eye. You are right now actually breathing in cadmium oxide nanoparticles, and you wouldn't know about it. However, the low dosage in the United States, you will not be affected. However, in industrial nations such as China and Japan, the doses you'll be breathing in can be detrimental to your body. Now, specifically, I looked at the effects of cadmium oxide nanoparticles on hypoxia. You ask, what is hypoxia? It is the lack of oxygen, the lack of the oxygen concentration in your blood. Now, hypoxia is regulated through hypoxia-inducible factors, or HIF. Specifically, I looked at HIF-1 alpha. Now, HIF-1 alpha is upstream to genes such as erythropoietin, VEGF, and INOS. I also looked at nitric oxide synthase, or INOS. Many people may know erythropoietin, or EPO, from the Tour de France, or blood doping. Many of the bicyclists, such as Lance Armstrong, were injecting themselves with erythropoietin to increase the concentration of oxygen in their blood, so they could have better performance in the Tour de France. Many bicyclists were also disqualified for doing this. So it's a little fact that actually kind of has to do with what I'm working on. Now, we found in previous studies, or I'm personally found, but it was found in previous studies that the hypoxia genes, as well as the downstream genes, are turned on when exposed to these cadmium nanoparticles. I also looked at the effects on pregnancy. So we were looking really, as an overview, at the effect of these cadmium oxide nanoparticles on the blood concentrations in the fetuses. So previous studies have found that cadmium can cause stillbirths or miscarriages during pregnancy. They've been found to be very detrimental in high doses. So what is the reason? What is the why? What is the how? Previous studies in my lab have found that daily exposure to these chemicals at a very low dose, 230 micrograms per milliliter, is actually the same dose or an equivalent dose to that a human breathes in an industrial nation such as China or Japan. So we were looking at a real-life scenario in a mouse model. And what they found was that there was an increased weight of the placentas at gestational day 17.5. Now, gestational day 17.5 is approximately, again, the second trimester, beginning of the third trimester in a human. So they were able to find that there was a change in the weight at the second trimester at even a low dose. Now, what is the why? And how can we find the reason to stop it, or maybe really anything else, and be able to understand this mechanism? So, the purpose of my study is to quantify the amount of HIF-1 alpha and INOS, the two genes I spoke about earlier, their expression in both their proteins and mRNA in the placentas of cadmium oxide nanoparticle-induced mice, of course, compared to control. And it was hypothesized that these nanoparticles would increase the concentration of both HIF1-alpha and iNOS. Now, what we did was female mice were paired randomly with male mice and were plugged at gestational day 0.5. Everything was done at 0.5 because the gestational day was overnight. Now, they were plugged, and 4 days later, they were going to be exposed to nose-only inhalation from the cadmium oxide nanoparticles in a closed environment. Now, gestational day 16.5, we separated the mice and were preparing them for sacrifice. And at gestational day 17.5, the female mice, pregnant mice, at 2 trimesters in, were sacrificed and the organs were harvested for use. Now, the results of my study, we found that there was a significant increase in the gene expression of iNOS compared to control, as you see in this here. However, we found no significant difference in the gene expression of HIF1-alpha compared to control. Now, in maternal organs, we found no difference in both HIF1-alpha and iNOS. Now, what is the why? What is the how again? As we looked at protein expression, we realized that when the protein of HIF1-alpha was put over a Western blot and expanded based on size, as you can see here, the expected size is at 75 kDa. However, we also found a smaller size of approximately 46 kDa. This means that the HIF1-alpha was degraded during the process, which may help explain why we did not see a significant difference in the gene expression. Now, HIF1-alpha is degraded by EGLN1, so if we wanted to find a more accurate result for HIF1-alpha, we would look earlier on, and we do the sacrifice early on in time. Now, what we did find was significant results in iNOS, and this may help explain a correlation between cadmium oxide nanoparticles and fetal hypoxia. So, to restate my purpose, it was to quantify the amount of HIF1-alpha and iNOS expression in the respective proteins in mRNA with the sensitive cadmium oxide nanoparticles induced mice compared to a control. And we did find there was a significant impact on the iNOS gene expression. From this, we can conclude that the correlation is possible, and it may help explain its toxicopathophysiology. And understanding these mechanisms will help allow us to assess the risk of cadmium exposure in the environment, such as cigarette smoke, exhaust fumes, or even Shrek glasses. I'd like to thank my mentors, Dr. Judith Selikoff and Dr. Jason Blum, the entire lab at NYU, Carol Hoffman, Lauren Rosenblum, and Mr. Sujay Alvankar, the STIR classes of 2009 and 2012, and the amazing teachers who helped me through all of this, Lydia Madigan, who's in the back. I love her very much, it's very helpful. And my family and friends for all their support through this whole process. Thank you, and I'll not take any questions.
Sam, I have a question.
Sure.
Does cadmium accumulate in the body, or is it?
Yes, it's actually found to not be water soluble. So as it accumulates in the kidneys and the liver, because those are pretty much organs that help filter the human body, when it accumulates there, it can lead to organ failure, pretty much.
And the second question that I had is that, so, based on all the different information that you presented, is it truly, it was known to be a carcinogen, but then it's regulating its gene expression? I guess the question is its effect really genetic or physiological?
Her question was, is the effect genetic or physiological? Now, they've looked at the effects of cadmium for, I almost want to say, a century now. In the 1940s, they found high doses of cadmium in Japan that caused a disease known as a tai-tai disease, or ouch disease, as it is in Japanese. And it caused a lot of neurological disorders, which help explain that it can be genetic, because it can affect the genetics. However, the cadmium itself is very harmful to the body, because previously against the control, we found no differences. The control, there was no effects, negative effects on the control when only exposed to air. However, we looked at a different type of cadmium oxide nanoparticles. Nanoparticles is a whole new field that has actually started in this past decade, and I'm very happy to be a part of it, but it is very new, and we are doing preliminary tests on these certain types of chemicals. So from what we're looking at right now, we have opened up really questions like yours to all of science and all in the apparatus we have two cadmium rods. We have to keep them saved away so we're not exposed to them. They're actually, we send a current through them and it actually ionizes